hear me. So thank you for taking the time and for having invited me to make this presentation. So my name is Oleh Wowkodaw. I'm president of Blue Eden CleanTech Inc. We are a clean technology company. Our focus is in using a variety of proprietary electrochemical and thermochemical processes in order to unlock value from various different waste streams, liquid to and
Oleh, your
yes.
mic is breaking up a little bit, so just talk slowly into your mic and I think it'll be all right.
Okay, I will slow down if I have the time. So we focus on the circular economy. Our processes are thermochemical and electrochemical in nature. We recover value from liquids and also from solids. Our team is heavy on the engineering side, so we have significant decades of experience on the team in the area of technology development and in the area of technology rollout into the market as well, both in Canada and also globally. Food companies such as, for example, Schlumberger, mostly in the oil patch, mostly oil field related, in the energy industry, that sort of thing. So the core process that we're focusing in as a company here is what we call our Olethros process. Olethros means to decompose materials into their value components. So that is the reason why we chose that name. Our focus, or one of the key areas that we're focusing this technology on, is in the processing of WEE, or WEEE, which is waste from electrical and electronic equipment. This is a very important issue globally in the area of recycling and reuse. Approximately 25 million tons of WEE are generated annually on a global scale, and only about 20% of that is actually recycled. Typically, the easy to remove components that can be taken out are removed, but that leaves a significant amount of residual material that ends up in basically in landfills. This becomes a toxic problem in landfills. It also becomes a toxic problem in other processes that can process this, such as, for example, incineration. This particular problem is expected to grow globally as a result of a number of factors, such as, for example, the electronic life cycle, which is very quick, that sort of thing. So hence it generates a lot of stuff that ends up being thrown out. Product demand, population growth, and also the need for strategic materials that are currently being recovered through difficult mining processes, which can be helped by basically a reuse model or a circular model. Sorry about that. Our process provides a path of value extraction from waste. We typically take wasteful materials that would create toxic waste if they end up in landfills, and we recover from these very valuable materials. In doing so, we also do not create some of the toxic byproducts that are typically generated through other processes that we compete against. Specifically, I'm talking about halogenated compounds, chlorinated compounds, for example, through things like PFASs and fire-resistant materials that are found in electronic equipment, which make electronic equipment very difficult to recycle. Our process is highly efficient, highly effective, it is profitable, and it is also scalable. We typically address waste in processes that traditional processes just cannot handle on their own. And as a result of that, we can provide a global solution and a global market opportunity for our company. The components of our Olethros platform are actually twofold. We have a thermochemical process, which is the core of the process. We call that the core Olethros process. This uses pyrolysis. I'm not sure if you're familiar with pyrolysis. Pyrolysis takes materials such as plastics and decomposes those under heat in an oxygen-free atmosphere in order to take out various different components. It takes out gases, it takes out liquids. It also creates a solid waste residue. In addition to that, we've got our electrochemical processes, which are clear blue and pure blue. These are processes that handle the toxic waters that are generated through the Olethros process. and basically purify the water for reuse. They also permit us to use the additional, let's say, value extractive processes through metal extraction using basically electrochemical processes. This is an example of what EO-Lefros can actually accomplish. So we can handle complex plastics, including plastics that contain basically fire retardant type chemicals. We can handle okay, fine industrial dust, automotive shredded material, carbon-based shredded material, as well as glass fiber shredded material. So it's a mixed bag of very complicated materials that are difficult to recycle because they are all integrated with each other, and it is difficult to handle them with a single process. EO-Lefros can actually handle this very, very nicely and in a very uncomplicated fashion. So what do we get from our process? We get metals and fibers on the bottom, and we get chemicals and energy as well. This is an example of a typical WEEE shredder residue. It can contain about 6% metals in its let's say raw form. Once it's processed, we can create a solid waste residue that can contain up to 20% metals. What you see in here is copper over here. You can see rare earth elements, very significant component. You can see a significant component of platinum group metals as well, amongst other things. This is a snapshot of what EO-Lefros looks like. So the pyrolysis is over here. That's the core of the process. In this case, we're using 1,000 kilos of shredder waste residue. From this, we can generate about 550 kilos of solid waste, which is where the metals end up being concentrated. And then we also recover a significant amount of heat, of which about 26% is used to run the process itself. So it's a very efficient process. If you're looking at our cash flow projection on this, on a modular form, we're looking to commercialize a 12-ton per day platform in 2024. This particular platform will create about 50% solid waste residue, which includes metals, as well as 35% high quality pyrolysis oil, which has a significant value for the chemical industry, and 15% gas, which includes about 50% hydrogen out of that 15% as well. So it's a very nice basically model for extracting value from these waste materials. The cost of this 12-ton per day module is estimated currently at about just under $5 million, and it should generate, based on commodity prices, about $10 million of revenue per year, of which if you look at on a per ton basis, this represents before tax about $1,800 of value per ton of waste that we process. This is a very lucrative model. It can create net cash flow after tax of about $5 million on this particular modular platform, and on the let's say a 10-year after tax discounted cash flow basis, that's about $35 million per platform. So this is a very nice model for us. We are getting actually a lot of interest in terms of the potential of this from potential investors as well, because of the fact that this is basically a clean mining process. So it addresses business and basically the reuse recycling business and the strategic value that we add to, let's say, the need for these metals and components. So I should mention that this particular cash flow model does not include site costs. So this is just the module cost, the operating costs related to the module itself. What are we looking at in terms of the plan moving forward? We've got I think it's a $2.7 million ask for this program. It's a phased program, of which we're looking at the first component being $150,000 for technology validation, for market analysis, both on the feedstock side and also on the market potential for the components that we create as well. This particular phase we're expecting to undertake in 2022, and that'll take us to the next phase, which is a $2.3 to $2.5 million ask, which is to build a pilot plant in Alberta and to run this over an extended period with various different feedstocks in order to optimize the technology, to integrate the various different components that make the entire platform work, and then to scale up into full commercialization in 2024. Questions?
All right. Did you add in the cost of the acquisition of your feedstock into your list there?
You know what? That's actually, we're working on that as we speak right now. We're working closely with ARMA here in Alberta, and I'm not sure if you're familiar with ARMA. They're the Alberta Recycling Management Authority. They're the quasi-government agency that collects all the money from electronic sales and then allocates that money, and then becomes kind of the fabric that holds together the collectors of e-waste and the process of e-waste. So basically, we're working with this authority in order to establish the appropriate, let's say, understanding of sourcing and the cost of sourcing. That is actually part of our validation program, the first 6-month program.
Okay. And I have another question about another couple questions, but there's a couple of questions in the chat. One is about, do you have patent protection on your technology?
So to an extent, yes. Basically, our core technology, which is Oleh, is going to be licensed exclusively through us. Okay. And so to us, it's be licensed exclusively to us. So it is patent protected, and it'll be available to us through an exclusive license arrangement. The water treatment technologies are our own proprietary technologies. So they are actually process protected by Blue Eden itself. There are components of that are patented, but these are basically proprietary processes.
Okay, and Ryan had another question about, can you comment a bit on your operational uptime or capacity factor when you estimate 12 tons per day? Seems like a lot of throughput to sustain, especially if it's solid or physical. So, and how much waste or unreclaimable is generated from 12 tons per day?
Actually, okay, if I were to look at this, the operating capacity and throughput capacity, which I think is what you're asking about, this is really something that we will address through our pilot project. So basically, once we establish, the objective of that first phase is that we're going to run a small quantity in order to extract the outputs, and then we will take a look at what is going to be involved in refining the extraction of those outputs instead of just sending those to a smelter. You can always send these things to a smelter, but we want to do better than that. There are some, let's say, some processes that involve the ability to dissolve certain valid components out, and so there's various different things that we want to test out. We want to optimize the process, and then run this thing to an extensive. It's a 6 to 9 month, let's say, pilot project where we will use a pilot scale plant that we will build here in Alberta and run this for an extended period of time in order to validate our operating assumptions and optimize these. So I can't tell you that 100%. We've done some, let's say, pilot plant operation with our partners, but we have not done those directly ourselves. And that's really what we would like to do in order to understand this fully.
Mm-hmm. Michael asked what your ideal customer looks like.
Okay, so we've got basically our model is a commodity sales model. So our customer ultimately is actually the commodity market. So if we produce platinum group metals, if we produce rare earth elements, gold, for example, it's actually it's like being a mining company without having to worry 10 years of getting the approvals to develop your mine and having enough, let's say, enough mineable ore available to you, because the access that you will have is through the waste that's basically currently going to landfills. So on the supply side, I don't think there will be an issue at all in accessing this. On the basically marketing of our value products, I don't think there will be a problem at all, because it's a commodity that we're looking to market. We're not looking for customers that will buy the actual plant. We're looking for the commodity buyers.
Okay, and I was just wondering about your the residuals from the process. Like, what are the chemicals? And I mean, are you flaring your heat off? Like, what kind of energy is being produced? Because you just said energy in big buckets. Yes. And so what are you doing with it? So
the energy that's produced, first of all, it produces heat. So we have residual heat energy that we can use. It produces syngas. Most of it would be in the form of methane and hydrogen. 50% of it is actually hydrogen that we generate. There's also some carbon monoxide that's generated and carbon dioxide as well. So we would selectively extract the value gases, and we would actually use the hydrogen as a chemical feedstock to upgrade some of our carbon dioxide into methane, and potentially use the hydrogen as a chemical feedstock for other things, instead of just basically using it for heat generation. Although you can use it through through a, basically you can regenerate energy using hydrogen from a fuel cell as well. So in the area of our pyrolysis oil, we produce a high quality pyrolysis oil, which has a significant light component. Basically, that there's a high volatile component, which would be quite useful for the chemical industry. We're currently looking at assessing the value of that within, let's say, the Edmonton sector with the refineries, in order to see as to what the market. We're not talking about very significant quantities because we're a small operation, but there's still some value that we can generate per, let's say, per barrel of that particular pyrolysis oil, either as a fuel oil, which would be the base value, or as a highly refined value add into the refinery industry as well. So we're looking at that also. In the solid side, there is a component. Once we extract the metals, there is a component of solid waste, which would be carbon based, mostly carbon, which can be incinerated. That's basically just fuel. Okay. And then in the area of water, of course, we're looking to purify the water with our electrochemical processes. So the water would be recycled or reused once we clean that. I hope that answers your question.
That was my other question, was about water, because if Alberta Environment and any of them, if they always have lots of questions around the water that's used in the process.
Christy, that's a very good question, because of course, both in flaring, in off gases, especially with things that could have halogenated components, it's basically a very sensitive issue. And the same thing with water. If there's anything that gets concentrated in the water, we've got to be able to take that out. Electrochemistry does it for us. We actually have a process which we call our pure brew process, which can take out any carbon base. It just breaks the bonds. It doesn't matter if it's PFAS or if it's dioxin or if it's pharmaceuticals or if it's bacteria.